All right. So now you guys understand. Is it warm in here? Okay. So now you guys get the differences between the nastic movements and the circadian rhythms and all those kinds of things. We know about our hormones. We know about which hormone does fruit ripening. Like if I'm told to put two fruits together in a paper bag to ripen one, what hormone does that have to do with? And how can that ethylene hormone get from one fruit to another if they're just in a bag together?
It'll give it off.
It'll give it off. It's a gas. Ethylene is a unique hormone in that it's a gas. It has a very simple, small molecular structure, so it can just waft out of one and affect another one, right? So you heard of like one bad apple spoils a whole bunch. That has to do with the ethylene release from a climacteric fruit or from a fruit that's decomposing. So people who ship fruit, they quickly learn things like which fruits you can keep together and which ones you can't. You know, some fruits put out a lot of ethylene gas, and they'll rot other fruits. You know, the effect of one will affect the other. You know about the two hormones that cause plants that are necessary for plants to do any growing at all. What are the two hormones?
Cytokinin
Cytokinin is one.
and auxin.
Auxin's the other one. And which side of the plant does auxin come from? The top. And cytokinin comes from the bottom. Yeah. Auxin comes from the shoots, cytokinin comes from the roots. All right. We got a hormone for germinating seeds. That's gibberellin. Okay, the hormone for germinating seeds is gibberellin. If you hit seeds with gibberellin, it'll make them here. So here's like a normal cabbage, and then here you see the cabbage has bolted. Okay, when the cabbage bolts, it's no good for eating anymore. It erupts out and flowers. Okay, so it's necessary if you want the cabbage to produce any seeds, but it will kind of ruin the cabbage as a cabbage. So here's an unbolted cabbage, and then here's what happens when they bolt. This is also gibberellin. Okay, so this is the impact of gibberellin on the plant. The plant stretches out very dramatically. It's not doing a whole lot of growing. It just does a whole lot of stretching out.
Yeah.
Right? So when we make cabbages at all, that's a plant that produces very, that's breeding plants that are going to produce lower amounts of gibberellin than what's maybe normal for the progenitor of cabbages, which would have been. You can see it's a much more open sort of plant, right? So yeah. All right. So gibberellin says bolt out. Gibberellins are also this is not their primary role in plants, but they are necessary for producing, when we create seedless varieties of plants, we need them to make normal sized fruits, okay? Because one thing that the seeds do is that the seeds release gibberellins, and the fruits are expecting gibberellins in order to reach their full size.
When you get like that giant pumpkin they had back in like Wisconsin or something, that was just like so humongous. Did that have like a more of an increase of gibberellin?
I don't know. I don't know, and I'm sure when you get into like high-end bonsai and competitive stuff, they know about plant hormones, and there's maybe some doping.
Yeah, probably
like
a little bit of adding some stuff.
Yeah,
to it,
a little adding some stuff can probably get some interesting effects, because certainly plant hormones can create all kinds.
Does that create it to be inedible or anything like that?
No. I mean, there's toxicity for plant hormones, and if you eat too much of some of them are more toxic than others and stuff like that. There's all kinds of different things that can be used as plant hormones. So there's the natural ones, which are very rare substances produced in very small amounts. But then we find other substances that act like plant hormones, right? That the plants confuse them for hormones. And this is actually a major thing in biology and chemistry. There's a lot of chemicals that different organisms will confuse as being one of their hormones, right? Like plants make sterols to modify their cell membranes, and human beings mistake those sterols for estrogens, So those plants, what's that?
I watched a documentary about that.
Yeah, so those plants in certain, like when you had Olympic athletes like eating way too much soy and stuff like that, they were getting female hormone basically from that, and it can create harmful effects, or it can be used even medicinally if you know what you're doing and stuff. So there's also the less hilarious circumstance where things like, you've heard of like no BPAs and stuff like that, right? And why do we care about there being BPA in anything? Well, bisphenol A was something that was used to soften up plastics. Like, you guys remember having one of these way back in the day?
Yeah.
They had that soft plastic head that glowed from the inside. Man, I was so envious of my cousin's glowworm toy. And those things were all laced with BPA to make the plastic soft. So it improves the, when they want to make different plastics with different characteristics, and one of the things they use is bisphenol A and stuff like that. Well, problem with bisphenol A is that the human body mistakes it for being a hormone. Okay, so the human body's like, is this thyroxine? I'm not sure what to do with this. So it affects the rate of cellular growth, and we know it has harmful effects, right? Because you generally don't want exogenous hormone effects on you. Your body's usually managing its hormones very well, and you don't want something else hitting you. So that's why we have like no BPA stuff. Of course, a lot of those plastics also have other things that affect the body as well. So what we find in plant biology with stuff like this is that we just manufacture these chemicals that the plants think are, they hit the plant like hormones. And so they make like literal tons of this in California for the seedless fruit industry to get those seedless fruits to reach their full size. As you can see here, the effect is quite dramatic on these seedless grapes. And if you've ever had like seeded grapes, they're often huge, right?
Yeah.
Like you can get seeded grapes that are like this big around, and then like seedless grapes are usually like this big around. So it's a tremendous difference in effect. Okay, so that's just a few plant hormones.
So did they take the BPA out of the inside of the canned vegetables and fruits?
I don't know if they're still using BPA for that or not.
I did learn that in one class.
Yeah.
The waxy
Yeah.
lining.
It used to contain BPA. I don't know if it
yeah.
still does or not. Yeah. Another thing to worry about is receipts.
Yes.
You should consider receipts and fabric softener sheets to be filthy. You should wash your hands after you touch them, because they're some of them are covered with these things, and they again act as female hormone and thyroxine and things like that. And man, if your hormones get screwed up, it can cause you a lot of discomfort. It can be really bad. A lot of health problems from that. So, all right, that's basically it for plants. There is a chapter after that, flowering plants reproduction, but if you open it up, you'll see parts of the flower, which we talked about. We thought there's double fertilization. We've already talked about that. So lead-ins and things like that. There's fruits. I don't think we have to know the fruit stuff, the difference between a petal and a hesperidium and a group, or a multiple fruit and an aggregate fruit.
What's the technical differentiation between, or definition between a fruit and a vegetable?
It's really easy. A fruit is the swollen ovary of a plant. Okay? So a tomato is a fruit because when the tomato flowers, the origin of the tomato, it's a seed-containing, structure that has a lot of flesh in it. And a pumpkin and a cucumber, all those are fruit. Broccoli is not a fruit because it doesn't have seeds. When you slice a broccoli down the middle, there's no seeds.
Yeah.
But the broccoli is an inflorescence, so if you let it go, it will produce lots of little tiny fruits. Not very tasty or soft or sweet ones, but mustard, fruits. Okay.
Interesting.
So yeah, lots of plants have fruits that you would think of. Like potato isn't a fruit, but potato has little fruits. Potato has little berries.
Yeah, they grow on
Things like that. So, oh yeah, at the end here they have like tissue culturing of plants, figure 2713. That's a technique where we can, remember I was mentioning how auxin and cytokinin can be used to cause cell division. If you manage the amount of auxin and cytokinin that the plant is exposed to, you can pretty much drive growth however you want, and really make the plant go crazy. I used to do this for years in the lab. And you can use this to take a tiny piece of tissue and grow new plants from it. Or you can take a tiny piece of tissue and grow hundreds and hundreds of, or thousands of plants from it. So like what's happening here is that this is like basically a plant tumor that's being created by the hormones in that nutrient media. And then when we take it off there and put it on a different regimen of hormones, it will produce roots or shoots, however we want it, depending on how well we know how to do it with that particular plant. And every plant is different in how it responds to the hormones and everything like that. So this is a plant tissue culture right here, and then you can add different hormones and get it to erupt, hopefully, into plants like that. And if you do it wrong, it never comes out of, it just stays a little tumor forever and it won't ever come out. But yeah, you can control it, and that's useful for making copies of plants that don't produce seeds, or all kinds of other situations. Like there's circumstances like there's a tree in Africa that's like the last of its kind, like this one sacred tree, and there's no others of it anywhere in the world, and like people keep coming and taking pieces of it because it's a sacred tree, and it's like it's in extreme danger of extinction. So we use tissue culture for doing things like that. Okay, that's it. That's the end of the plant chapter, and I think we're ready for the exam on Thursday. Let's see.
I won't be here. My husband's got an award ceremony I don't need to be to, so,
Priorities.
yeah.
We do drop the lowest.
Okay, is there any way we can push it to Tuesday? Or, I know you talked about that last time.
Okay, I'll tell you what, I'll put it to a vote for the class. We'll do what I did for the other class. The other class voted by one vote. It was actually a hung jury. The class split down the middle, and then one guy changed his vote, and they switched it to having the test on Thursday. If we don't have the test on Thursday, I have to start invertebrate evolution on Thursday. And you guys will have to pay attention as we learn about animal stuff, but you will also have the plant stuff over your head. Okay? Are you having your lab quiz today?
Yeah.
Why are you having your lab quiz today?
So that's just how she,
That was not how it was
Yeah.
on the calendar.
So
Mhm.
we
because
literally
it
have one
was,
light.
yeah, like every other
Yeah.
Tuesday.
But
And
it's not on
Yes.
chapters 25, 26, and 27.
Right.
Yeah.
So, what do you mean? But it is on the plant stuff.
It's on
You're
the
doing-
plant stuff,
You're doing
yeah.
the plant stuff, okay.
The
So-
end, the end of 22, chapter 23 and 24.
Yeah,
So it's like plant anatomy.
uh-huh.
Yeah.
That's gonna fall in that quiz, okay. So, yeah, that's right. Yeah, I'm just got a little confused because my other 102 class is having theirs on Thursday, but that's also, yeah. So, yeah. So you don't have the issue of having a lab quiz and an exam the same day if you do have it on Thursday, but let's just put it to a vote. Who wants to have it on Thursday? Raise your hand. Who wants to have it on Tuesday? Raise your hand. I think the Tuesday
Yes.
people have
Thank
it.
you, everyone.
So,
Thank you.
Yes.
all right. I had some students who were really